All right, hello, my name is Juan Romero, and this is a quick video demonstrating the very basics of gradient descent. Um, a little more specifically about how neural networks learn. Okay, so how does a network learn? So we need an algorithm that takes in data and tweaks parameters to achieve the desired outcome. These parameters that I mentioned in the previous videos, these are called weights and biases. Now, the goal here is that when the model is trained on labeled data, the model itself can now label new data based on the ones it was trained on. And we have a picture on the top right here. Somebody wrote a number. I'm assuming that's a number 5. And we want the model to tell us this is a number 5. But in this particular case, it guessed 6. So we tell it that it's wrong. We get our average, and that's information that we can use to train a new model. Now, what learning comes down to is it's finding out the minimum of a certain function, and we'll get to that in the next slide. Now, to start off, the weights will be initialized randomly. Because of this, our first run will very likely not give us the output that we want. So we need a cost function. We need a way to let the model know that from X input, we need Y output. Now, in these pictures to the right, notice how that when the model outputs what we want, the total of the sum of the function is small. Now, after we do this for every single input, we want to get the average. This average is going to tell us how good our model is. Now, let me explain the pictures to the right a little more. So just assume for this particular picture that this first row here is the performance, I guess we could say, of it guessing 0. And the second one, it's guessing 1. This one is guessing 2, and so on. This here guesses 3. Now we can see that somebody wrote a number 3. We can tell that it's a number 3, but this model obviously doesn't. Now in this first picture, let's say that this is our first run with randomly initialized weights. As you can see that all of these numbers here, they look very random. In this number here, in this particular example, somebody wrote a 3. So that's why we have a 1.00 here as our expected outcome. Okay? Because we want this number here to be a 3. But as we can see here, these weights here are random. So when we execute this function, we're going to get these numbers here. And then when we add up all of these numbers, we're going to get a 3.37. So this here is our first run. This is the run where the weights really don't mean anything at this point. They're just random, but this is what we get with this function. Now, over several iterations, let's say that our model is getting closer to what we actually want. In this case, you can see how these weights up here and these weights down here are now closer to 0. And this weight here is now closer to 1. So when we go ahead and we do this calculation and we add them all up, and you can see even here, these individual squares are now smaller, right? All of these numbers are pretty big, relatively speaking, to these. These are all very small. When we add up all of these numbers, we can see that our total sum is actually really small. And this is a gauge that we can use. The smaller our total sum is, the better our model is at guessing what number our input is. But now we need to know how to minimize the cost function. After we get something like this, how do we know what to tweak? I'm sorry, how do we know how to tweak? Now when we're dealing with our average parabolas, finding local maximum and minimums is relatively easy. It's not that hard. But when we have thousands of parameters like we do in our neural networks, things get complicated. So what can we do when we have such a big graph like we do when handling neural networks? Well, we can just grab a random point. Sorry about that. We can just grab a random point. And at this point, we can find the slope of that point. Now, if that slope is negative, like shown here in this picture, we can move to the right. If that slope is positive, we can move to the left. Now, when you keep repeating this process, at some point you will get to a minimum. Now, when we find our local minimum, this point is essentially going to be a vector with thousands of parameters. These parameters are going to be able to tell us by how much to either increase or decrease the original weights to guide us towards that goal that we need. This algorithm is called backpropagation. Backpropagation I will explain more in my next video, but this essentially just finds the values needed to minimize the costs. They input them back into the original function and rinse and repeat. So let's bring these key ideas together. At the end of the day, the actual idea of how neural networks learn, I think, is pretty simple. It's just a bunch of math. But neural networks learn by adjusting their internal parameters, called weights, like I said, based on the data that they see. Now, like I explained, this learning happens in three major steps. The data goes through the networks, producing a prediction. Right? This is in our first run, like I said, when those weights are randomized. Now that second step is the calculation. This prediction is compared to the correct answer using the loss function. Using that function that I mentioned, that is the cost function. And then finally, it's that backpropagation. Now, I didn't go too into detail with backpropagation because that's going to be in the next video, but essentially this network calculates how wrong it was and then uses gradient descent to adjust its weights little by little to make better predictions next time.